I'm going to try to record this as flawlessly as possible and making sure that I enunciate the words as best as possible, right? Because I noticed that you guys could hear me good, but sometimes you guys couldn't hear me good either. Um, on last on yesterday's clip. So that being said, hello. My name is Christian, and I'm gonna be discussing nested queries today, how they work, and how you can develop them, and what are the use cases. So, first things first, I just want to clarify that you can achieve the same results using nested queries and joins. It's basically the same thing. One is a little bit more easier to read, and another one is not. Later on, we can get into the performance differences between using joins and using nested queries. Since and there is a significant performance difference if you're using nested queries. So you need to be careful and mindful if you are working with a lot of data and you are working in a database that it's charging you for the query execution time. I was practicing before I started recording some queries and just getting used to the syntax for concatenating different strings because here you don't actually use the concat function, you actually use this double bar, and that represents basically what you're going to be concatenating. So I was practicing that since it is different across different database management systems. For instance, in MySQL is basically similar to SQLite from what I've seen so far. Postgre is a little bit different. Postgre you use you're allowed to use the concat function and SQL Server Management Studio. You can just use the plus, and it would automatically concatenate it, and that's all. All right, so let's start off with nested queries. So there are different ways, there are different places where you can use a nested query. Remember, if we look at all queries, they most of them will use the following syntax. There is the select statement from where if applied, or if you have an aggregate function group by having, then order by, and this is either best for us, descending and ascending, and any limit the number of records that you want to pull. So this is basically what all SQL statements are built upon. And if you see them as objects, you're going to notice a pattern. Like for instance, select selects objects. What are the objects? Columns. So we can, for instance, we can do, let's see if it works. Just to show, select, and let's put here, select first name from employee as first name, that's first underscore name, just I confuse it since it is a column name. And then let's do select last name from employee as last name from employee. All right. Okay, you notice this actually works. So it's repeating the records because it's just displaying the amount of records, right, for each one, for each of the 9 records that you do. There are a total of not 9 records on the employee table, so that's the reason why we're getting a repeated value here. But the reason why I'm doing this is because I want to show you that, hey, yes, you can indeed um, select, or we can just eliminate this right in. It's going to do the same thing. So it's bringing up a table, or the first column from the employee table, and then it's displaying that first value on the employee table again, and repeating it for each and every one of the records. So this is interesting. This is showing the functionality of, hey, the employee record, or in this case, the nested query in the select statement is an object. So any column 1, column 2, column 3, can also be query 1, query 2, query 3. And this is actually beautifully demonstrating once we're doing the aggregate functions like count average, min max, etc. And using those does, well, min max are scalar values, but the aggregate functions like count. Average is not an average, that's a scalar value. But anyways, once you're using the aggregate functions, you're able to see this in action, right? So that being said, let's start off with nested queries. Now, let's do the first example. Let's say that you are tasked with getting each employee's name and the total number of orders that they've handled. So let's do that. We know that we need to get, there's a way where we can do that, and it's just by doing inner join, right? We can do select e dot first name e dot last name. We're specifying first and last name from the employees. Then we can do count, an aggregate function, of course, o dot id, inner join from employee e, inner join order. I know that order we have an issue because order is also a reserved word in SQLite. Order O on e dot id equals o dot employee id. Since we do have an aggregate, remember aggregates require you to group them by. And what are we going to be grouping them by? It's going to be e dot first name, e dot last name. We can just get away with just doing e dot first, right? But hey, here we go. And let's alias this column as total orders made. All right. There we go. You see, we're getting the total orders, and we can, in order to see a little bit better, let's add a order by clause, and let's do descending. Hmm? Oh, I'm sorry. Order by o.id descending. Alright, so I actually need to enter the aggregate function count order.id descending. There we go. Alright, so now we get three columns. First name, we have the last name, we have total orders made, we have the amount of orders that were made for each employees, right? Since we're referencing the count column, and yeah. Now this is a lot if you look at it. Like, hey, we're doing an inner join, we're selecting the first and last name, we're doing the aggregate function, then we do the group by, and then etc. Right? So one of the beautiful things of nested queries is that you can actually reduce this. And here's how we're going to reduce it. If we select first name, last name, and select count. Let me look at the syntax. Select count star from order where order dot employee ID equals employee ID as order total orders made from employee. Wait, there's an issue. There's a syntax error and I can't see it, so I. Oh, where? Here we go. Okay, if you notice, we get the same exact table that we got it, and we can add the. So since we can actually add the order. Actually, let's do the order by clause here. Order by. Well, no. Let's do the order by at the bottom here. Order by. Order by. Totals. Orders made. Oh, this is great. Yeah, I'm gonna add it here. Order by, and I'll explain the reason why it's not working. All right, so I know this is a lot. Just bear with me here because we are discussing other topics that haven't been discussed. But now it should work. Actually, the order by clause is not working. I think I'm gonna need to figure that one out later on. Regardless, let's just keep it simple for now. Okay, so we have here the names of each of the customers, of the employees, I'm sorry, with the total orders that they handled, right? And if you notice, we're not doing a join. The only join that we're not actually doing a join, we're just calling a column. In this case, we're calling the amount of records that are linked to every employee. So if we go to the orders table, right? I mean, let's pull up the orders table. Select star from order. If you notice, each order, each record is an order. Each order is going to have a customer ID, going to have an employee ID, which is assuming that this is the employee who was handling the record. It's going to have an order date, etc. Right? So what that query, what that subquery is doing, this, all it's doing is saying that, hey, I want you to select all the records from the order table where order.employee ID equals employee ID. So here it's technically doing the inner join or the join itself. How it works, since we do have an aggregate function and we're not doing a group by, what it's saying is the SQL, the SQLite backend is saying like, hey, okay, so how many records do I have for each employee ID? And one of them was 157. It was displayed there. And it just keeps adding the information, right? So let's go ahead and run this initial query again. I just wanted to share the logic on how this nested query worked. And now I notice that in order to do the order by clause, we just add this, which it's a nightmare, right? But I just want, let's do in the bottom. So, and let's do order by, there we go. Oh, wait, that's ending. Now, all right, awesome. So this is the reason where, so the reason why I can't use the alias that we made for that column and the order by clause is because there is a sequence in which the objects are created in when a query is run. So the first thing that's going to be created is the from. That's the first thing that the SQLite serve, and this for this case, the engine, this SQLite engine is going to be pulling from. Then the second is where. Then if there's any order by or group by, and it's group by, then it's order by. And then finally it's going to be the select. So that's basically the order of operations. And we can look at this, SQL order operations. There we go. So from, where, group, having, select, distinct, order by clause, and limit. So in this case, SQLite is actually, let's do this. Let's try total orders made. Actually, yeah, we can use the alias. We can use the alias or scratch what I was saying, but we need to be careful sometimes with this because not all products are going to be the same. Some products have the order by. The order by clause is goes before the select, which if that's the case, you're not going to be able to use an alias, and you can just reference either the aggregate function or subquery like I did previously, right? Just checking if there's anyone there. Oh, there's no one here. I didn't think anyone was going to be logging in today. I'm just going to continue. But hey, yeah, this is basically an example of how to use a nested query. And we did a, we used a similar example on using the inner join, of course, so you guys can see the difference. And I just want to make sure that you guys understand, hey, if you guys end up using a subquery, just ensure that it might impact performance and it might impact how long the query is going to run. All right. So let's do another example. Let's do an example for the where, right? How a nested query on the front, in the front actually. So let's do anything. Let's do this. Select order ID, total value from, and we're going to have the nested query. Let's run the bottom. Select order ID from unit price times quantity as total value from order detail group by order ID. Where, actually, let's just do that for now. Should work. Wait. Yeah, the order detail. Oh, I didn't put a closing parenthesis, and I think I have an additional parenthesis that's needed here, and now it should work. There we go. And this is being evaluated afterwards first, so we can do order by total value descending. Hey, we have it. We can round this actually. Hopefully we have the round function. Round. There we go. Much more beautiful. Looks better, much better. And we can also format. We can round and format. Let's do SQLite and format. That is actually SQLite. Okay. Well, I'm not going to do that. Let's just leave it as is. There's a way you can actually format after a certain spaces. Anyways, it all changes by each product once. Anyways, here, what we are getting is there we go. It looks better. All right, so we're getting the order ID. We're getting the total value for each order. In this case, it's $17,250. That's a lot for an order, right? Just imagine if we had that amount of money where we can actually make an order that costs almost $20,000. I can only imagine what what they were ordering here. And we can actually look at it, right? We can select, we can look at this order ID specifically and see what items and products that you ordered and why is it 17,000? Because it's not just items, it's the quantity, since we are summing up the total value of each of the orders. And the way that we do that is by adding that unit price times quantity, which gives us the total price. And this is just simple mathematics, right? Anyways, if you notice, the difference here now is that we have the subquery within the from clause. And the reason why we were able to access the alias that's within this subquery from the from clause and access it directly in the select statement is because, remember, the from clause is executed before the select statement. Remember the SQL order of operations, first a from or any join clauses or clause group by having select this thing. Since we're doing the from, the nested query is within the from, and we're doing an alias within this nested query, it's being created before that outside select statement, right? And there are different use cases and different samples on where you can definitely use nested queries. You can use them that you can use them at the having. You can use them at the group by. You can use them at even by the order by. You can basically use them in any place on the queries. So the takeaway here is that yeah, you can basically do the same thing that you're doing joins. By the way, you're going to be able to get the exact same thing doing joins, group bys, doing the following. But if you notice, this looks better than having the inner join and then on foreign key equals primary key equals foreign key, etc. Right? So this looks way better and is easier to read. But performance-wise, it might impact the performance, so that's something that you need to take into consideration. I think that's gonna be all for today. If you guys want, we can practice different types of nested subqueries, nested queries, and having and group by and anything else. And yeah, I think that's just gonna be all for now. I hope you guys have a great evening. And if you have any questions, comments, or concerns, you can definitely leave me a comment here on the Discord or on the YouTube channel. Have a great day.